In the previous video, all the videos whatever I have prepared, in those videos I have discussed about the acid base indicators, concept of acid bases, classification of acid bases, and then I have discussed in the last video, that is the properties of bases, acids. So in this video we will discuss about first of all the preparation of bases, then chemical properties of bases, and at last we will discuss about the uses of bases. Clear? So let's start the video, and good morning to all. So today's topic is preparation of bases. First of all, the first topic is preparation of bases. So in the preparation of bases, the first one is called as from metals. Okay, from metals. So if we will take the metal like any metal, when reacts with oxygen, they are giving metal oxides, and we know that the metal oxides are basic in nature, or they are comes under bases. I have told you that metallic oxides are basic in nature and the non-metallic oxides are acidic in nature. So when we are talking that metals are reacting with oxygen, it gives metal oxide. So metal oxides are bases. So we can say that from whenever the metal reacts with oxygen, they are giving bases. For example, if we will take magnesium plus oxygen, what we will get? Magnesium oxide. We will get magnesium oxide. So magnesium oxide is a base. Magnesium oxide is a base. So this is the first method for the preparation of bases. Second method is action of water on reactive metals. In the previous video, I have discussed that there are some series that is called as reactivity series for the metal. Means metals are arranged in the increasing order of their or decreasing order of their reactivity. So the metals which are most reactive are called as reactive metals. Example: sodium, potassium, calcium, as well as we will consider magnesium. So what is the action of water on reactive metal? For example, if we will take sodium, when reacts with water, it gives sodium hydroxide, which is a base, plus water as a byproduct, a hydrogen gas as a byproduct. So it evolves hydrogen gas. And I have told you the hydrogen gas burns with a pop sound. So that is the characteristics of evolution of hydrogen gas. Means if the gas is burning with a pop sound, then we can say that gas is hydrogen. So in this reaction, what happens? The reactive metal when reacts with water, this reaction is tremendous, means very violent reaction. Will immediately the sodium metal catches fire. I will show you sometime that how the sodium catches fire when it come in contact with water. So when it come in contact with water, it gives sodium hydroxide, which is a base, and it liberates hydrogen gas. Similarly, if potassium will come in contact with water, it will also form potassium hydroxide, plus it liberates hydrogen gas. So this potassium hydroxide is a base. So this is the second method for the preparation of what? For the preparation of bases. Now we will come to the third method, that action of water on soluble metal oxide. So there are some metal oxides which are soluble in water. For example, this sodium oxide, when it is treated with water, they are directly giving sodium hydroxide. So this is the third method in which the oxides of the soluble metal oxides, when reacts with water, they are giving sodium hydroxide. Which is a base. Next method, fourth method, we will talk about by double displacement reaction. displacement. Already you know that. What is double displacement reaction? The reaction in which there will be exchange of ions, those reactions are called as double displacement reaction. Whenever there will be exchange of ions, means if two salts are there, their ions will exchange their compound, then those reactions are called as double displacement reaction. So in the double displacement reaction, we will see one example. Suppose we are taking iron chloride. We are taking iron chloride and we are treating with sodium hydroxide. We are treating with sodium hydroxide. So when we are treating with sodium hydroxide, in that case, what will happen? They are giving hydroxide of iron. Hydroxide of iron means FeOH3. It gives the hydroxide of iron which is basic or which are bases, because already I have told you, according to Arrhenius concept, the compound which furnish hydroxide ion in the aqueous solution is known as bases. So by double displacement method, here there will be exchange of ion. So the second product is NaCl. Clear? So here we can see, due to the exchange of ion, it gives the another base, that is the ferrous hydroxide, that is the ferric hydroxide. Okay, means the hydroxide of iron. Now the fifth method is the by action of oxide on metal sulfide. By action of oxygen on metal sulfide, we know that metal sulfide, for example ZnS, zinc sulfide. When treating with oxygen and it is heated, zinc sulfide, it is a metal sulfide. I have told you in the previous video, sulfide means when sulfur ion will be there, that is called as sulfide. So this zinc sulfide, when reacts with oxygen, it will give what? Zinc oxide plus sulfur dioxide. It gives zinc oxide plus sulfur dioxide. It means the metal oxide which it is giving, that is base. That is base. Generally we know that oxide of what? Oxide of any metals are generally basic in nature. So here we are getting the zinc oxide which is base. And what is the peculiarity of this reaction? We are getting the sulfur dioxide gas. So what is the peculiarity of this reaction? It evolves sulfur dioxide. Clear? So from the zinc sulfide, when treated with oxygen, it gives zinc oxide which is basic in nature, and it evolves a gas, liberate a gas, that is sulfur dioxide, and it having a peculiarity. I have told you what is the smell that sulfur dioxide having. So this is the fifth method for the preparation of base. Now the sixth method, by decomposition of salt. We know that calcium carbonate. You know about calcium carbonate? So calcium carbonate when heated, okay, it gives calcium oxide. Again we are getting metallic oxide. Metallic oxides are bases. So metallic oxide, again we are getting a metallic oxide, and what is the specialty here? It evolves carbon dioxide gas. So whenever the carbonate of the metal are heated, it gives their oxide. Which are bases. Metal oxides are bases, and it evolves carbon dioxide. If carbonate is there, carbon dioxide. If sulfate is there, sulfur dioxide. Like this, whatever radical is present, its corresponding gas will evolve. That is the non-metallic oxide will evolve. Clear? So this is the sixth method. One more method, it is not there, I will explain, from ammonia. One more method, seventh method, that is from ammonia. Okay, the fourth method is the ammonia. So how ammonia, NH3, there is no hydroxide, no OH is there. So you will tell that ammonia is a acid. No, but ammonia is not an acid, ammonia is a base, because according to Lewis base, the compound which donate electrons are known as Lewis base. So ammonia is a base. So we can say that when it reacts with water, it giving a base. It giving a base, that is ammonium hydroxide, which is a weak base, which is a weak base. So generally when the ammonia reacts with water, it gives the ammonium hydroxide, which is a weak base. That's why this is the seventh method for the preparation of base. For the preparation of base. So whenever ammonia reacts with water, it gives ammonium hydroxide, which is a weak base. So now the next topic is chemical properties of bases. Chemical properties of bases. So the first property is that strong alkalis. What do you mean by strong alkali? Strong alkali means the soluble bases are called as alkali. So strong alkali generally NaOH and KOH. NaOH and KOH. So when this NaOH is treated with carbon dioxide, what happens? It gives sodium carbonate Na2CO3 plus it gives water. So whenever this sodium hydroxide reacts with the carbon dioxide, it gives sodium carbonate Na2CO3 and water as a byproduct. So this is the first chemical property of strong bases or strong alkalis, that they will absorb the carbon dioxide from air, because we know that carbon dioxide is present in the atmosphere. So it gives sodium carbonate because it forms carbonate, sodium carbonate and water as a byproduct. Second is the neutralize acid. As we already know that acid can neutralize the base to give salt and water. Similarly, the bases are also neutralizing the acid to give water plus salt or salt plus water. So we can write that, for example, NaOH when treated with any acid like HCl. So what it gives? It gives NaCl plus H2O. Water is the byproduct and salt. So here what happened? The bases and acids are nullify the charges and forming the salt. That's why this is also called as neutralization reaction. It is also called as neutralization reaction. But it is not true that always it will gives a neutral salt. It will also gives acidic salt or the basic salt. So it depends upon the strength of acid and bases. But whenever the acid bases are neutralizing the acid, they are giving the salt plus water as a byproduct. Okay, now we will come to the third property. Third property is that precipitate as insoluble metallic hydroxide. Insoluble metallic hydroxide means which are insoluble in water. So it will precipitate, because insoluble mass is generally precipitating. So it will precipitate that insoluble metallic hydroxide when added to the solution of salt of heavy metal. Like copper, zinc, iron. These are considering as heavy metal. So this heavy metal, salt of this heavy metal, for example copper sulfate. This is the salt of copper. Salt of copper when treated with, suppose ammonium hydroxide, which is a base. Ammonium hydroxide, which is a base, when treated, they will give ammonium hydroxide. It will give ammonium sulfate. It gives ammonium sulfate, and it will give a insoluble one, that is copper hydroxide. Copper hydroxide which will precipitate in the form of pale blue color. The characteristic color of copper hydroxide is pale blue color. So this is the insoluble precipitate. This is the insoluble precipitate of the heavy metal whose salt is used here. So here the heavy metal, that is the copper sulfate salt, when treated with the base, it gives ammonium sulfate, and the precipitate of insoluble metallic hydroxide, that is copper hydroxide, which having a characteristic color, that is pale blue color. So this is the third chemical property of bases. Now fourth, alkali with ammonium salt. Ammonium salt, for example, ammonium chloride. And alkali means what? Sodium or potassium hydroxide. When they are treated with potassium or sodium hydroxide, first of all they will give NaCl, that is the salt. Secondly, they will give water, and the peculiarity of this reaction is that it evolves the ammonia gas. What is the specialty of this reaction? It liberates ammonia gas which having a pungent smell, which having a pungent smell, which having a pungent smell. Clear? So whenever the ammonium salt, for example ammonium chloride is an ammonium salt, treated with the alkali, that is the sodium hydroxide or potassium hydroxide, it gives salt plus water, and in addition to it, it gives ammonia gas which having a pungent smell. So these are few chemical properties of bases. Few chemical properties of bases. So at last we will see some of the uses of bases. Uses of bases. What are the uses of bases? Uses of bases. So let's see what are the uses of bases. First of all, NaOH, sodium hydroxide. So sodium hydroxide is mainly used in what? First is the soap preparation. Soap preparation means in the saponification reaction. Saponification reaction. Saponification means what? Saponification reaction is generally used to prepare soap. Similarly, it is also used in the laboratory for quantitative and qualitative analysis. So this is the uses of sodium hydroxide, which is also called as caustic soda. The commercial name of sodium hydroxide is caustic soda. Second is the KOH. Potassium hydroxide is mainly used as an electrolyte in batteries. In battery. There are many types of battery are there. Primary, secondary, many types of battery are there, but in the batteries generally in the form of electrolyte we are using this potassium hydroxide, electrolyte in battery. Another, soap preparation. Next, third is the calcium hydroxide. This is another base which is used to prepare bleaching powder. And this is also used removal of hardness from water. So what do you mean by hardness of water? Means whenever the water which do not gives good lather with soap, generally when we are applying soap over our hand, if we are not getting good foam or lather, then that water is called as hard water. That water is the hard water, means the soap do not works properly in hard water. So for that reason we have to remove the hardness of water, and the hardness of water can be removed by the calcium hydroxide. This thing you will learn in higher classes, that is in class 11. That how the hardness of water will be removed. So generally the calcium hydroxide is used to prepare bleaching powder. This is one of the important compound, bleaching powder, because it is used in disinfection of the toilets and bathroom. It is used for the purification of the purification of the drinking water. So bleaching powder having a commercial use. Similarly, this calcium hydroxide can also be used for the removal of hardness from water. And last, fourth is the magnesium hydroxide, which is used as an antacid, which is also called as milk of magnesia. And milk of magnesia is mainly used as an antacid. Means whenever in the stomach there is the hydrochloric acid is there. For the digestion, the acid is there. When the acid secretion is more, when the acid secretion in the stomach is more, we are feeling uneasy. We are feeling irritation, and that is called as acidity. That is called as the hyperacidity, and prolonged hyperacidity leads to peptic ulcer. That's why we have to feel comfortable, we are using the antacid. And antacids are nothing, these are simply the bases which neutralizes the excess of acid secrete in our stomach. So in this way, these are few uses of bases, or we can say these are the some bases which we are using in our day to day life. Thank you.